Hey everyone, so we're getting started off today by talking about systems of equations. We spent the last few class times talking about the different types of linear equations and linear inequalities that we see, so different ways to express linear forms of mathematics. Now we're going to talk about expressing systems of equations. So that's when we have more than one equation or more than one inequality in our set of things that we're looking at. So to define systems of equations, we would specifically say that it is two or more equations with the same variables. For the most part, we are just going to be comparing x and y, but if we start to look at these explained in kind of those real-world examples, we'll be able to use any variable and graph it, substituting those for x and y. So the next thing we need to talk about is what the solution to a system is. Now, there's two ways that we can do this. The first way is we can do this graphically, and that's by finding the point on our graph x and y where those two lines would intersect. Now, if we had more than two equations, we would then be looking for the point where those equations would all intersect at the same point. Now, the next one is to look at where they are algebraically, what that solution would look like algebraically. Well, again, we're still looking at a point. We need both x and y to be the same and make both equations true. In other words, if I plug in a value for x, it should give me the same value for y for both of those equations. So we want to talk about those types of solutions because they come in multiple ways. We have an option where we can have one solution. That's where we have our first line intersecting with a second line, and they intersect at just one specific point. When we have one solution, we can write that as just one x, y point. Sometimes, though, we'll have parallel lines. And as we talked about a few lessons ago, parallel lines never intersect. So they would look something like this, or two railroad tracks running alongside each other. And we say these have no solution. In other words, we use this zero with a slash through it. That tells us no solution. There is nothing here that will give us an answer. The last thing is when we have the same line. Sometimes we are given the same expression, but using a higher coefficient, a higher common factor. And so this would have an infinite solution. Then they'd be two lines stacked on top of each other like that. And when we say we have an infinite solution, we'll just use our infinity sign. So now we want to solve these systems of equations by graphing them for today. And so to do that, we have three steps we're going to follow. The first step that we're going to do is to rewrite those equations in slope-intercept form if they are not already in that form. And remember, slope-intercept form is that y equals mx plus b. The second step is we're just going to graph each line. The final thing is to identify the solutions. And we can do that by either saying this is the point where these two lines exactly intersect, seeing that they are parallel lines and they would never intersect, there's no solution, or they are the exact same line, so they have infinite solutions. So let's go through our first example here. We have example 1, and I'm going to use both my pink and blue pens, and so I'm going to do this first equation in pink. So we have y equals x minus 8. And to graph this, that means I need to go down 8. That minus 8 is my y-intercept, so I go down 8 on my graph. There's down 8, I make a point there. And then my slope, since this is just x, that tells me my slope is really 1. In other words, I go up 1, and to the right 1. So up 1, over 1. I'll make a couple more. There we go. Or I can do this the opposite way, where if I were to go down 1, I would have to go to the left 1. Either way you go, you get this nice straight line that comes through those points there. And now my second equation I'm going to do in this blue pen here. And again, I'm going to start from my y-intercept, that plus 1. So that tells me on my y-axis, I go up 1 point. And from there, my slope is -2. So that tells me I go down 2 every time I go to the right 1. Or I go up 2 and to the left 1. Either way you do that, you're going to have a line that comes through just like this. And you can see that these two graphs would intersect at this point right here, which happens to be over 1, 2, 3 on x, and it goes down 1, 2, 3, 4, 5. So these intersect at one specific point, and that point is 3, -5. So our solution is to point 3, -5. Now let's take a look at a couple of other solutions. So let's take a look now at these first couple examples, 3 and 4. I will share the rest of this document with you, so if you want to practice some more problems before you get started with your assignment, you can do that. But let's get rolling with questions 3 and 4. So question 3, we have our two equations again. However, we don't have them in standard form. So I need to, or they are in standard form, and I need to put them in slope-intercept form. So I need to solve for y in both of my equations. I'm going to do this first one here in pink again. So we have -3x plus y equals 8. Well, to get y by itself, I need to get rid of anything else that's on this side with it, which would be this -3x. To move that off of the side with y, I need to do its opposite. So that means I need to add 3x to both sides. So now I have y equals 3x plus 8. Well, I've now solved this equation. I have y all by itself, and there's only one y. So that means that I can go ahead and graph this equation. I'm going to go up 8 because that's what my y-intercept tells me. That plus 8 means I go up 8 points. And my slope tells me I'm going to go up 3 for every one I go to the right. So if I try and go up 3, my graph isn't quite large enough to do that. So the opposite way that I can go is if I go down 3, that means I'm going to go to the left 1. Remember, when we plot our slope, it's either they're both going to be positive or they're both going to be negative moves for this slope here. I'm just going to keep going because this is quite a steep line. I want to make sure I am accurate. Now, the nice thing about your assignment is that DeltaMath is going to be able to graph these much more smoothly than I can do by hand. But now let's move on to the next part of our problem. Now we have -x plus y equals -2. Again, this is in standard form, so that means I need to change it to be in slope-intercept form. So I'll write that down here, blue. -x plus y equals -2. Well, to get y by itself, I need to get rid of anything else over here first, which means I need to do the opposite of -x, which is plus x to both sides. So now I have y equals x minus 2. Well, if I want to make my graph come down 2 for its intercept, then I'm going to follow my slope, which is 1. So up 1, over 1, up 1, over 1, 1 over 1. However, I'm noticing that the farther up I go on my graph, the farther away I get from my pink line. That tells me that I need to go the opposite direction so I can get closer. So down 1, left 1, until I reach that point where they would intersect. And we can see that they do now. And the point they intersect at would be right here, which is 1, 2, 3, 4, 5 on x, and 1, 2, 3, 4, 5, 6, 7 on y. However, these went left and down, so that means that's -4, -7. So again, just one solution for this graph. Number 4, let's check out number 4. This first equation, I have x plus 2y equals 4. So that means that this is in standard form. I need to switch it so that it is in slope-intercept form. So that means I want to get y all by itself. To do that, I need to get rid of this x. Since I have a positive x, I need to subtract x from both sides. So now I have 2y equals -x plus 4. Well, I don't want 2y, I want just 1y. So I'm going to divide both sides by y. And I have to divide everything by 2. So that means if I have a -1x divided by 2, this is now a -1/2 x. And then 4 divided by 2 would give me a positive 2. So let's go ahead and graph this first equation. I'm going to come up 2 on my graph. And my slope tells me that I go down 1. For every 2, I go to the right. So down 1 over 2, down 1 over 2. Or if I go up 1, I need to go to the left 2. And I can draw a line through those dots. Now for my next one, this is already in slope-intercept form. So let's go ahead and plot these points. My intercept is at +2, so we can see that they intersect at their y-intercepts. However, if I start plotting this slope, I can either move this negative to the top with 1 or down with 2. Either way, it gives me the same number. If I go down 1 over 2, down 1 over 2, or if I come up 1, left 2, I'm still following the same line that I had before. That's because after I solved this first equation to be in slope-intercept form, it became the same equation as my second equation. Since these two lines run together, they're the same equation, all of these points would be solutions, giving us the solution of infinity. So now, again, if you want to try out these next couple of examples, you certainly can. I'm going to post the key to these in Schoology. If you would like to see the answers, make sure that you got these right after you tried them out. With that being said, your assignment for today is in DeltaMath. Go ahead and check that out. And as always, if you have any questions, please email me, send me a message, let me know.